Okay, today we're going to look at the factor theorem and how to factor a cubic equation so you can find those x-intercepts. Maybe you remember there's a question in the notes where Mr. Autry's got a cubic equation like this. It's x cubed minus 14x squared plus 49x minus 36. Well, if you want to find the x-intercepts of any function, you let y equal 0. So he did that. He let y equal 0. But then he wrote down x minus 1, and then he wrote x squared minus 13x plus 36, and then he factored that. But how did he do that? Well, there's something called the factor theorem. Now, let me show you this. The factors of this equation, if we can factor this, we're going to be able to find the x-intercepts really easy. And the way we get at those factors is we start by looking at the constant term, this 36. Now, our answers for the x-intercepts in this question are going to be factors of 36. And the first numbers that go into it are 1 and minus 1. Then 2 and minus 2, 3 and minus 3. There's a lot of factors of 36. But what you do is you just try out 1. And always start with 1 and see if it works. If you put 1 into this function, you're going to get 1 plus 49 is 50. But if you put 1 in here, you're going to get minus 14 you're going to get minus 50. It's going to give you 0. Well, that means it must be an x-intercept because it makes y equals 0. Well, we've got one of the x-intercepts. But we know that if whatever thing makes it 0, if a makes it 0, then x minus a is a factor. So what we can do, we can get started. We put down a bracket, x minus 1. Now, it's actually really, really easy. You just take a look at this number and this thing in front. The only way to get x cubed is to go x times x squared. It must be x squared to make x cubed. Then you're going to go minus 1 times some number on the end here. To get minus 36, it's got to be plus 36 to make minus 36. By the way, you know it's going to be a squared term, and then an x term, and then a number. So the only tricky part is this linear term right here. Like, how many x should it be? Should it be positive? Should it be negative? Well, this is how you get started. Let's just take a look at the x's. There's 49x here. Well, if we go x times 36, we get 36x. But we see we need 49x. So somehow we're going to have to add 13x for whatever we put in here. Well, here's a minus 1. It's going to get multiplied by something to get positive 13x. It's going to have to be minus 13x. Negative 1 times negative 13 will give me plus 13x. And 36 plus 13x, that'll give me the 49x. Everything else will work out. Well, that's it. That's the key thing. Actually, this linear term is the hardest part. It requires this thinking. Just carefully go back through this thing, and it's the same procedure for all our cubic equations. Well, now we've got it. X minus 1 times x squared minus 13x plus 36. Now we can factor this. If we did get stumped for some reason and couldn't factor it, we could use the quadratic formula, but we don't want to. And now we can see x minus 4 times x plus 9. Minus 4 times minus 9 is positive 36. Minus 4x minus 9x, that gives me the minus 13x. Look at now it's easy to see that 1, 4, and 9 all make this equal 0. Later on, when we sketch it, you can see the x-intercepts of this cubic equation, 1, 4, and 9. So that's the theorem. Look back here, just at the beginning, just one more time, I just want to say, we picked 1. Often then we maybe would try minus 1. Just keep trying the smallest factors you can. Then you would try plus 2 and minus 2, plus 3 and minus 3, then plus 4 and minus 4. Just keep going through all the factors of this constant term. And you'll find one that makes it 0. Then you can get started. Well, I hope this helps. And I'm going to stop recording just now.